Hey, geometry, guess where I am? It's one of my favorite spots. I used to, when my kids were little, we'd come in and work and I would come up here. Do you know where this is? It's right above, kind of above the library. There's a little secret chamber up here. And I used to have my kids come up here, we'd explore. And there's actually a door that goes up onto the roof up here. So, all right, let's do some geometry. Okay, geometry, we're going to do the first section of chapter 5. And I have to say there's quite a bit of vocab and whatever, but I don't think anything in here is too not under or too difficult, okay? So let me just remind you of what a bisector, a perpendicular bisector is. If I have a line segment, a perpendicular bisector, just like it sounds, crosses perpendicularly and it bisects the angle. It cuts this in two. So this distance is the same as this distance. Okay? They go on to give you a couple other theorems about that, though. Besides just that point being equidistant, Theorem 5.1 says if I pick any point, let me just pick a point there, call it x, that point is equidistant from the endpoints. If I pick a point there, that point is equidistant from the endpoints. Okay, so that's all Theorem 5.1. Theorem 5.2 is just the converse of that. If I start from the endpoints and I go the same distance, I'll go a distance of this much and this much, and I end up at a point. That point is going to be on the perpendicular bisector, okay? So it's just exactly the reverse of what we just did in 5.1. Now, applying that to triangles, you get something a little different. First of all, let me make sure you understand a word. If I have a line and another line, the point where they cross is called the point of concurrency. They're concurrent lines. I could have another line going through there, another line. That is all the point of concurrency, okay? So if I take a triangle and I figure out the perpendicular bisector of this side, and I figure out the perpendicular bisector of this side, and the perpendicular bisector of this side, these are all going to meet at a point of concurrency. And it's Theorem 5.3. It says if you take the perpendicular bisector of any triangle of the three sides, they're going to meet at a point, and that is called the circumcenter. Okay? So there's a little vocab for you. Now this would be for an acute triangle. If all these three sides are less than 90 degrees, you would find the circumcenter inside the triangle. If I did a right triangle, then I take the perpendicular bisector, and the perpendicular bisector here, it's actually going to meet on the hypotenuse, the center of the hypotenuse. So it's not going to be inside the triangle. That's for a right triangle. For an obtuse triangle, where one of these is greater than 90 degrees, then I'm going to take the perpendicular bisector, and I guess my drawing's a little messed up, but the perpendicular bisector is actually going to meet outside the triangle. All right? So the circumcenter does not always have to be inside the triangle. Okay. So the last thing from this chapter is they want to remind you what angular bisectors are. So I have an angle, and I bisect that right down the middle. They want to remind you that that is making this angle the same as that angle. Okay, that's what an angular bisector is. But in theorem 5.4, they go a little bit beyond that, and they tell you that if you have an angular bisector, the distance, like you pick any point, pick that point. The distance from here to there is going to be the same as the distance from there to there. Okay? Any point on this angular bisector, the distance to the two edges is going to be the same. And then lastly, theorem 5.5 is the converse of that. If you start anywhere here and you go up that distance and then you start somewhere here that's the same distance away, so this distance is the same as that distance, they're going to land on the angle bisector. Just like we just did, let's take that information now and apply it to a triangle. If I take the angle bisector here, the angle bisector here, and the angle bisector here, they're all going to meet at a spot, and that is no longer called the circumcenter, that is called the incenter. So if you take the side perpendicular bisectors, they meet at the circumcenter. If you take the angle bisectors, they meet at the incenter. Unlike the other kinds of, unlike a circumcenter, it doesn't matter what kind of triangle you have, the incenter is always going to be inside the triangle. And in fact, you're able to draw a circle with that as its center that touches all three sides every time. Okay, I think that is all the vocab, and I'm sure they're going to have you do lots of fun stuff with that vocab, but at least now you have the tools to do that. Okay? All right, I'm done.